Good day, everyone. I am Master Ryan, and this is Mathematics for Active Learning for Pathom 6. Our topic for the day is all about word problems about volumes of three-dimensional shapes made up of cubes and cuboids. Before we proceed to our discussion, let us have first a short review on how to solve the volume of cubes and cuboids. First, cube. It is made up of six curved faces. All the edges of the cube have the same length. The formula in solving for the volume of the cube is equal to length times length times length. However, cuboids, a cuboid is made up of six rectangular faces or four rectangular faces and two square bases. The formula in solving for the volume of the cuboid is length times width times height. We consider the same formula in solving for the capacity of cube and cuboids. Let's take a look for our example number 1. The base of a rectangular tank measures 21 centimeters by 15 centimeters. It is filled with water to a height of 4 centimeters. Find the volume in the tank. Express the answer in liters. Consider 1 liter is equal to 1,000 cubic centimeters. Since the tank is in rectangular shape, we can use the formula in solving for the volume of the cuboid. That is, volume of the water in the tank is equal to length times width times height. Since the length of the rectangular tank is 21 centimeters, the width measures 15 centimeters, and the height of the water inside the tank is 4 centimeters, then multiply the three values, and the product is 1,260 cubic centimeters. But according to the problem, we need to express the answer in liters. That is why we need to convert cubic centimeters to liters. That is 1,260 cubic centimeters divided by 1,000, and the quotient is 1 and 26 hundredths liters. Let's have example number 2. A rectangular tank has a base area of 10 square meters. The tank contains 78 cubic meters of water. Find the height of the water level in the tank. In doing the solution for this problem, we can use the formula in solving for the volume of the cuboid, which is volume is equal to length times width times height. Since we are solving for the height of the water in the tank, we can manipulate the formula and turns to be like this: volume divided by base area, which is equal to 78 divided by 10, and the quotient is 7 and 8/10 meters. Therefore, the height of the water level in the tank is 7 and 8/10 meters. Let's have example number 3. James built a water pit in the shape and size as shown below. He wants to fill the pit with water. What is the capacity of the pit? This time, we are solving for the capacity of a three-dimensional shape, but we are still using the same formula as volume. For our first solution, we need to solve for the capacity of the big cuboid. The same formula, length times width times height. Since the length is 18 millimeters, the width equals 10 millimeters, and the height equals 60 millimeters, multiplying the three values, and the product is 48,000 cubic millimeters. For our solution number 2, we need to solve for the capacity of the small cuboid. The same formula, length times width times height. Since the length is equal to 60 millimeters, the width equals 10 millimeters, the height equals 40 millimeters. Multiplying the three values and the product is 24,000 cubic millimeters. Since we are solving for the capacity of the pit, we need to subtract 48,000 cubic millimeters by 24,000 cubic millimeters. The difference is 24,000 cubic millimeters, which is the capacity of the pit. We are down to our last example. A fish tank is in the shape and size as shown below. What is the capacity of the tank? In this problem, we need to do three solutions for this. The first solution, we need to solve for the capacity of the top and the bottom cuboid. The same formula, length times width times height, but this time, we are going to multiply it by 2 since the top and the bottom cuboid have the same dimensions. 12 inches times 12 inches times 3 inches times 2. 432 cubic inches times 2, and the product is 864 cubic inches. For solution number 2, we need to solve for the capacity of the cuboid in the middle. The same formula, length times width times height. Since the length and the width is 4 inches respectively, and the height is 8 inches, multiplying the three values and the product is 128 cubic inches. Since we are solving for the capacity of the tank, we are going to add 864 cubic inches plus 128 cubic inches. Therefore, the capacity of the whole fish tank is equal to 992 cubic inches. Do you have some questions? Now, let's practice. Answer the next word problem about volume and capacity of cube and cuboids. Here is the problem. An empty rectangular tank is being filled with water at a rate of 12 liters per minute. It takes half an hour to fill the tank to the brim. What is the height of the tank? So what do you think are we going to do first? Correct. We are going to solve for the volume of the water in the tank. Since a rectangular tank can be filled with water at a rate of 12 liters per minute, and it takes half an hour to fill the tank to the brim, which is equal to 30 minutes, we are going to multiply 12 liters times 30, and the product is 360 liters. We need to convert this one to cubic centimeter by multiplying it by 1000, and the product is 360,000 cubic centimeters. For our solution number 2, what do you think is the formula that we are going to use? Correct. We are going to use the same formula, which is volume is equal to length times width times height. Since we are solving for the height, change the volume into 360,000 cubic centimeters, the length, which is equal to 75 centimeters, and the width, which is equal to 60 centimeters. Multiply 75 and 60, which is equal to 4,500. Since we are solving for the height, we need to divide 360,000 by 4,500. And the quotient is 80 centimeter, which is the height of the tank. I hope you had fun. See you again next time. Thank you for watching.